morning, students. Chapter 8, Gravitation. Yes, you know word gravitation. Okay, you also know what is meaning of this word. If on Earth, if you have any object, irrespective of its mass, okay, if you drop any object, it is accelerated towards Earth, towards center of Earth. If you throw any object in upward direction, it will go up to some height and then it will again accelerate it towards Earth, towards center of Earth. That you know. Okay, so yes, it is a topic of great interest. Okay, what is gravitation? How each and every objects are accelerated, are attracted towards the center of Earth. Okay, so yes, right now actually we know this whole concept of what is gravitation and how Earth attracts. But before, okay, when these laws were not there, okay, what is Newton's law of gravitation, Kepler's law, etc., 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 they were not known. Okay, so before that, different scientists, according to that time period, they proposed some model, they gave some laws. Okay, so here this chapter gravitation, we will start with some history, as introduction. Okay, yes, some observations by Galileo that each and every object, it is accelerated towards the center of Earth. If we throw any object in upward direction, it is again coming back to Earth. Okay, if you visit any hill station, then yes, going uphill is difficult. Going uphill is difficult, but going downhill is easy. So why? So some observations were made by Galileo, and see, historically it was the Italian physicist Galileo who recognized that fact that all bodies, irrespective of their masses, are accelerated towards the Earth with constant acceleration. So first historical observation, it was recognized by Galileo. Okay. Now another interesting thing was motion of stars and planets. Okay, yes, stars. Okay, if we see stars, so they are stationary from a long time at some position. Okay, while the planets are revolving, means they changes their position. So it was a topic of great interest. What is governing laws? What are governing laws for such motions of planet, sun, earth, etc., etc., etc.? Okay, so for that, the more interesting objects are planets, which seems to have regular motion against the background of stars. For that, the earliest recorded model was given by, for planet in motion, was given by Ptolemy about 2000 years ago. Okay, first, the earliest recorded model for planetary motions, for motion of planets, were recorded by Ptolemy about 2000 years ago, called geocentric model. Now, in geocentric model, Ptolemy assumed that each and every celestial objects, means stars, all planets, and sun also, they are revolving around Earth. They are revolving around Earth in circular orbits. Okay, so again, the earliest model recorded was for planetary motion by Ptolemy about 2000 years ago, called geocentric model, in which he assumed that each and every celestial objects, they revolve around Earth. Clear? Okay, next more elegant model was represented by Aryabhatta. Okay, it is called heliocentric model. and in this model he assumed that sun is at center. Sun is at center. So what is difference between these two models? Okay, Ptolemy assumed that Earth is at center and all another celestial objects are revolving around it. But Aryabhatta assumed that no, sun is at center and another celestial objects are revolving around it. Clear about this? So yes, we have to remember these two models. Then Copernicus proposed a definite model in which the planets move in circles around a fixed sun. Okay, after so many years, Tycho Brahe spent his entire lifetime recording observations of the planets, and his compiled data were analyzed by his assistant Kepler. Okay, to see from the beginning, there are numbers of scientists who observed some phenomena. Okay, they gave their observations to in form of some laws, in form of some models. Okay, and one by one, their models and their statements and their models were represented, were proposed. Okay, at last Tycho Brahe spent his entire lifetime recording observation of planets. His compiled data were analyzed by his classmate Kepler. He could extract from the data three elegant laws that have go to by the names of Kepler's law, and which we will study in this chapter. Okay, first question of this chapter is Kepler's three laws. Kepler's three laws for planetary motion, and these all laws were known to Newton, which enabled him to propose his universal law of gravitation, which helps him to propose his universal law of gravitation. Okay, so see, it is one introduction, it is one history type that you have to remember. Okay, different scientists came. They gave their proposed model, proposed laws, okay, and then they were modified, they were rejected, etc. And yes, now in this chapter we have to study two most important things. First, Kepler's law of motion for planetary motion, and second, Newton's universal law of gravitation. Okay, so now we will see Kepler's three laws. Now we will see Kepler's laws. See, here it is. Kepler's law, first law of orbits. His law of orbit is simple. Okay, Copernicus, he suggested that all planets are revolving around sun in a circular orbit. But Kepler suggested that all planets move in elliptical orbits with sun situated at one of the foci of the ellipse. Okay, now what is elliptical orbit? What is ellipse? What is foci? That is question. Okay, but it is law. Okay, what is law of orbit? All planets move in elliptical orbits with the sun situated at one of the foci of the ellipse. This law was a deviation from Copernicus' model, which allowed only circular orbits. Now what is ellipse? What is ellipse? See, ellipse is one closed curve and circle is one special case of ellipse. Yes, the ellipse of which the circle is special case is a closed curve. Now how to draw ellipse and how it is? It's closed curve. So see, if I have two fixed points F1 and F2 like this. Yes, distance between F1 and F2 is constant. Distance between F1 and F2 is constant. Now take a string which is having its one end fixed at F1 and another end fixed at F2. Take one string. Okay, one end fixed at F1, another end fixed at F2. For example, like this, it is string. Okay, now take pencil here like this. Okay, take pencil here at this point, and now by keeping these two ends fixed, try to draw one curve. Try to draw one curve. Okay, you have to drag pencil. Okay, you have to drag pencil, and if you move pencil, two ends are fixed. Okay, then the shape formed by pencil will be like this. It will be like this, and yes, this shape, it is called ellipse. This closed curve is called ellipse. This closed curve is called ellipse. And yes, these two fixed points, F1 and F2, F1 and F2, they are called foci of ellipse. They are called foci of ellipse. Clear about this? They are called foci of ellipse. This shape, it is called foci. Ellipse. And this F1 and F2, they are called foci. Clear about this? Okay. See, one axis like this. It is named 2A. It is named 2A. Okay. And it is called major axis. It is called major axis. Clear about this? This axis, okay, it is 2B, and it is called minor axis. It is called minor axis. Let center of F1 and F2 is this one, O. This one, O. Clear about this? Okay, so O, suppose it is P, and suppose it is Q. Suppose it is Q. So yes, we can say OP is equal to OQ. OP is equal to OQ. OP is equal to OQ. Now see, it is major axis. OP means half of major axis. So we can say OP or OQ is equal to, it is only A, and it is called semi-major axis. It is called semi-major axis. Clear about this? So about ellipse, you have to remember this all data. First of all, how to draw ellipse. You can easily draw ellipse. How to draw ellipse? Okay. Then F1, F2 foci of ellipse. Their midpoint, it is called center. This axis, which is passing from two foci, it is called major axis. It is denoted by 2A. Perpendicular to it, it is minor axis. It is denoted by 2B. OP or OQ, it is called semi-major axis. Clear? Now if these two foci, that is F1 and F2, if they merged at a point, then it forms circle. Then it forms circle. Okay, if F1 and F2, they are merged at a point, it forms a circle. It forms a circle. Clear? So circle is special case of ellipse. So do you understand what is shape ellipse? So yes, first law of Kepler is okay, all planets move in elliptical orbit with sun situated at one of the foci of the ellipse. One of the foci of the ellipse, like this. Okay. If here it is sun, then all planets revolve like this. Then all planets revolve like this. Clear? Sun at one of the foci. Sun at one of the foci. Suppose sun is here. Suppose sun is here. Clear? Okay. So it is first law. Why it is called law of orbit? Because it gives type of orbit. Okay, yes, all planets are revolving in elliptical orbit. Clear? So yes, for today it is enough. Introduction and Kepler's laws in first law, that is law of orbit. Next two laws we'll see in next lecture. Okay, this is it for today.